Chapter 4, Loops, Part 6. Nested loops is when you put a loop inside a loop, such as if you want to print a table with rows and columns. It's helpful to use a for loop because typically you know exactly how many rows and how many columns you want. And you have one loop, you loop one time per row, that's your outer loop, and your inner loop would loop through each column. So it might look like this on a flow chart. Now, unfortunately, with the limitations of drawing tools, these lines are a little bit goofy. But however, if you set your outer loop, say you call your loop control variable for your outer loop x, and you want to loop while x is less than or equal to 10, then you set your inner loop control variable, let's say you want to call that n, equal to 1, and let's assume you want to loop through 4 columns, so n less than or equal to 4. Then you would print x raised to the power of n, increment n, and test again. So you would do that inner loop, the part that's shaded, for each column per row. Once you're done looping through your inner loop, you would print a new line, go to the beginning of the next line, and increment your outer loop control variable, in this case x++, and then go back and test x less than or equal to 10. So each single time through the outer loop, the inner loop will run all the way through. Here's an example, printing a table of raising x to the power of n. These columns print a header, so it's just printing out the header for the table. And then here's the rest of the code that will print out at line 25. It says double x equals 1, x less than or equal to x max, x++. And then inside the loop, there's a comment, print table row. So this inner loop will print one row, and it's going to be a column, each column in that row for int n equals 1, n less than or equal to n max, n++. And then we print out the x to the power of n, math.pow, x, comma, n. Once we go all the way through that inner loop, system.out.println will return us to the beginning of the next line, and we can go back up to line 26 and start the whole process again. That will cause this table to be output, which it's tough to do those superscripts there in Java, making it look good like in a console window and text output, but nevertheless, I think they've done a pretty good job. Here's some nested loop examples. If we want to print a rectangle of asterisks, 3 rows and 4 columns, notice the outer loop controls the rows and the inner loop controls the columns. In the second example, we want to print 4 rows and 3 columns, so the outer loop again controls the rows. The outer loop always controls the rows, and the inner loop controls the columns. We're printing 4 rows and 3 columns in the second example. In the third example, we're printing a triangle, so 1 column on row 1, 2 columns on row 2, 3 columns on row 3, and 4 columns on row 4. And how we do that is by our stop value of the inner loop. Notice the outer loops for I equals 1, I less than or equal to 4, I++, so that's obviously going to go 4 times. But the inner loop says for j equal 1, j less than or equal to I. So each time through the outer loop, the inner loop will loop a different number of times because the stop value is I, which does change each time through the outer loop. Here's another example where if we want to print a certain thing, if the loop control variable is divisible by 0, if it's even. So inside our inner loop we have an if statement. If j modulus 2 equals 0, we print an asterisk, else we print a dash. And then in the last example, we want to print a checkerboard pattern. Inside the inner loop, we say if I modulus n equals j modulus n, then we print an asterisk, else we print a space. Random numbers and simulations. One of the things that computing does really well is to generate random numbers and enable us to play games and simulate things in the real world or things that we can't do, like going to Jupiter or something. So let's think about playing games, because that makes an easy touch point for most of us. One of the things that we're going to do in this chapter is learn how to roll a die. We can simulate that. You know, you've all probably rolled a die at your life, a 6-sided die, and You can go turn up 1 or 2 or 3 or 4 or 5 or 6. You may have also seen spinning a wheel. You may have done that at a carnival or seen Wheel of Fortune on television. Spinning a wheel will randomly select a specific slice of that wheel. Or picking a card from a deck of cards. You can also use a simulation that involves looping through a sequence of events, such as days or certain events. I did this when I was living and working in Hawaii. We had a large number, I worked for a hotel, and we had a large number of Japanese tourists. And at that time, I don't know if this is still true, but at that time every year the emperor would designate a certain number of days in the year as lucky days. And if a Japanese citizen travels on a lucky day, they are said to be more likely to arrive at their destination. So we had to include that in our code. Here's an example of generating a random number. Math.random will generate a random number between 0 and 1, including 0, but not including 1, so it is a double. If we want to generate an int, we're going to have to cast that, such as in this example. Look at line 12. Line 12, we say math.random, so that's going to generate a number between 0 and 1, including 0 but not including 1. We multiply that by 6 to enable us to get up to a random number of 5, and then add 1. So we're not going to include 0 anymore because we're adding 1. So we're going from 1 to 6. Then we cast that to an int, and lo and behold, it gives us a random integer 1, 2, 3, 4, 5, or 6.